In September 2017, NASA made a drastic and highly calculated decision to deliberately destroy one of the most successful robotic explorers in human history. They took a $3.26 billion spacecraft, which had been flawlessly exploring the outer solar system for 13 years, and intentionally plunged it into the crushing atmosphere of Saturn to burn up like a meteor. Why would scientists murder their own creation? The answer is both counterintuitive and profound. They destroyed it to protect alien life. This is the incredible story of the Cassini-Huygens mission, a near disaster averted by a clever hack, and a discovery that forever changed our understanding of where life might exist in the universe. Launched in October 1997, the Cassini-Huygens mission was a massive international collaboration between NASA, the European Space Agency, ESA, and the Italian Space Agency. Cassini wasn't just a satellite. It was a flagship-class, 12,000-pound behemoth.
4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
Because Saturn is so incredibly far from the Sun, solar panels wouldn't work, so Cassini was powered by about 73 pounds of radioactive plutonium. But even with nuclear power, electricity was tight. All of Cassini's hardware, its science instruments, propulsion, and computers, had to share a 600-watt power supply. That is barely enough electricity to run this kitchen blender. Because of this, Cassini had to literally whisper its data back to Earth over nearly a billion miles away. To hear it, we relied on the Deep Space Network, monstrous 230-foot-wide radio antennas located around the globe. Cassini didn't go to Saturn alone. It carried a European passenger named Huygens, a probe designed to parachute onto Saturn's haze-covered moon Titan. But right in the middle of its 7-year journey, engineers realized something terrifying.
Exactly. They discovered a fatal design flaw in the communications equipment that would have resulted in the complete loss of all the data Huygens was supposed to send us. Huygens was too small to transmit directly to Earth, so it had to beam its data to Cassini, which would then relay it home.
And the problem was the Doppler shift, right, Leo?
Right, Olivia. As Huygens descended, it would accelerate relative to Cassini, stretching and compressing the radio waves. The hardware on Cassini was designed to handle the frequency shift, but the firmware completely failed to account for how the Doppler shift would alter the timing of the payload bits. It would have been unreadable garbage. Reprogramming the firmware in space was impossible, so they had to completely alter Cassini's trajectory.
How did changing the trajectory fix a software bug?
It's brilliant. They changed the approach so that Huygens' transmissions traveled perpendicular to its direction of motion relative to Cassini. This greatly reduced the Doppler shift, essentially bypassing the flaw. Thanks to that hack, on January 14, 2005, Huygens successfully landed. It bounced, slid about 30 to 40 centimeters, and wobbled to a stop. We found out Titan's surface has the consistency of damp sand made of ice grains, or even creme brulee, with rounded pebbles of water ice scattered across it.
Okay, but here is what I don't get. At the end of the mission, NASA crashed Cassini into Saturn specifically to avoid contaminating any of Saturn's moons with Earth bacteria. If planetary protection was such a huge deal, why were we totally fine intentionally crashing the Huygens probe onto Titan? It all comes down to chemistry and temperature. Titan is fascinating, with rivers and lakes of liquid methane and a surface temperature of minus 290 degrees Fahrenheit. Astrobiologists determined that this harsh, super cold environment would kill off any hitchhiking microorganisms from Earth. There's virtually no risk of Earth life surviving there. But there's another moon that changes everything. Enceladus. Initially, Enceladus just looked like a dead ball of ice. But Cassini discovered massive geysers of water ice and gas erupting from its south pole. Cassini actually flew directly through these plumes, tasting the water, and they found out it wasn't just ice. Far from it. They found evidence of a global salty liquid water ocean hiding beneath a 16 to 19-mile thick icy crust. Even more staggering, they found complex organic compounds in those plumes, specifically esters, alkenes, and ether compounds. We also suspect there are hydrothermal vents at the bottom of that ocean, which is exactly where we think life on Earth may have originated. Enceladus has the ingredients for life as we know it, making it perhaps the most important spot in the solar system to look for alien microbes. And that mind-blowing discovery is exactly what doomed Cassini. By 2017, after 13 years of spectacular orbital science, Cassini was running out of the rocket fuel needed to adjust its course. If scientists lost control of the spacecraft, there was an unacceptable risk that it could eventually crash into Enceladus. We simply couldn't risk contaminating a pristine, potentially habitable alien ocean with our own bacteria. So NASA planned the grand finale. Cassini was sent on 22 daring dives right through the 1,200-mile-wide gap between Saturn and its innermost rings. Finally, on September 15, 2017, Cassini plunged into Saturn's atmosphere, transmitting data about the planet's composition until the very last second, when its small thrusters could no longer keep its antenna pointed at Earth. Cassini died as it lived, a mission of thrilling exploration. It vanished into the giant planet it had spent its life studying, but the mountains of data it sent back will continue to yield new discoveries and reveal the secrets of our solar system for decades to come.